Imagine waking up tomorrow and discovering that a machine can write novels, create art, diagnose diseases, and even drive a car. Not in the future. Today. For some people, this feels exciting. For others, it feels terrifying. Because we've been told two completely different stories about artificial intelligence. One story says AI will eventually become a super intelligent mind that outthinks humanity. The other says AI is nothing more than a fancy calculator. But here's the strange part. Both of those stories are wrong. AI is not conscious. It isn't thinking like a human. And yet, it can still do things that once seemed impossible. So how does a machine made of code learn to recognize faces, understand language, and generate entire conversations? To answer that question, we need to open the so-called black box of AI and look at what's actually happening inside. And the truth might surprise you. Because the secret behind artificial intelligence is not magic. It's something much simpler. To understand modern AI, we need to go back to how computers originally worked. Traditional computers were extremely literal machines. They followed instructions exactly as they were written. Nothing more. Nothing less. If you wanted a computer to perform a task, you had to explain every single rule step by step. Imagine trying to teach a computer to recognize a cat in a photograph. In early programming, the instructions might look something like this. If the image contains fur and triangular ears and whiskers, then label the object as a cat. On paper, that sounds reasonable. But the moment you test it in the real world, everything falls apart. What if the cat is hairless? What if its ears are folded? What if the lighting hides the whiskers? What if the cat is partially hidden behind a chair? Suddenly, your simple rulebook becomes thousands of complicated exceptions. And the truth is, reality is far too messy to describe with rigid rules. That limitation frustrated computer scientists for decades, until someone asked a very different question. What if we stopped trying to write all the rules ourselves? What if we let the computer discover the rules on its own? That idea became the foundation of modern AI. Think about how a small child learns what a cat is. You don't sit them down and explain geometric shapes or biological classifications. Instead, you simply point at animals and say, "That's a cat." Then later, "That's a dog." After seeing enough examples, the child's brain begins to notice patterns. Cats usually have certain facial shapes, certain body proportions, certain movements. Eventually, the child can recognize a cat instantly, even if they've never seen that exact one before. Machine learning works in a surprisingly similar way. Instead of programming rules, scientists show the computer huge numbers of examples. Millions of images labeled cat. Millions labeled not cat. The system then analyzes those images and starts identifying patterns within the data. Patterns so subtle that humans might not even be able to explain them. And this is where something called a neural network comes in. The term neural network sounds complicated, but the idea behind it is actually simple. Imagine a giant system made of many layers. Each layer acts like a filter that examines the information in a different way. When an image enters the network, the first layer doesn't recognize objects. Instead, it detects extremely basic features, things like lines, edges, and curves. Those simple features are then passed to the next layer. The second layer begins combining them. It might recognize shapes like circles or corners. Then the next layer builds something more complex. Maybe it identifies textures, or outlines, or clusters of shapes that resemble eyes or ears. By the time the information reaches the deepest layers, the system has combined thousands of tiny details into a final guess. Cat, dog, car, tree. This process is called deep learning because the system learns through many layers of analysis. But recognizing patterns is only half the story. The real magic happens when the system learns from its mistakes. When an AI system first starts learning, it is incredibly bad at its job. Show it a picture of a cat, and it might guess bicycle. That's normal, because at the beginning, the system has no idea what it's looking at. but every guess is compared to the correct answer. If the guess is wrong, the system receives feedback. That feedback travels backward through the network and slightly adjusts thousands or even millions of tiny parameters. You can think of these parameters like knobs on a massive control board. Every mistake turns those knobs just a little bit. After millions of images and millions of corrections, the system gradually tunes itself. Eventually, the settings become so refined that the AI can recognize patterns extremely accurately, not because it understands cats, but because it has learned how certain pixels tend to appear together. Recognition AI explains things like image detection, but what about systems that create things, like stories, paintings, or music? This is known as generative AI. Instead of identifying patterns in images, these systems analyze patterns in language or visual data. Imagine reading millions of books, articles, conversations, and websites. Over time, your brain would naturally start recognizing which words tend to appear together. For example, if someone says, "The quick brown fox jumps over the," most people automatically know the next word, lazy. Not because they calculated it, but because they've encountered that phrase so many times. Generative AI works the same way. It studies enormous collections of human writing and learns the statistical relationships between words. When you type a prompt, the system predicts what word is most likely to come next. Then the next. Then the next. Those predictions happen incredibly fast, forming sentences, paragraphs, and entire responses. From the outside, it feels like a conversation, but underneath, it's a powerful pattern prediction engine. The reason AI feels intelligent is because it was trained on human data, human language, human art, human ideas. In a sense, AI acts like a mirror, reflecting patterns from the information we've created. That's why it can imitate writing styles, generate realistic images, and answer questions. But it's important to remember something. AI does not have beliefs, it does not have emotions, and it does not truly understand the world the way humans do. What it has is experience gathered from vast amounts of data, and the ability to find patterns faster than any human brain ever could. When people imagine artificial intelligence, they often picture something mysterious or futuristic. But the reality is much more grounded. AI is built on trial and error, patterns, feedback, and an enormous amount of data. It's a simple idea repeated billions of times until it becomes incredibly powerful, and we're only just beginning to see what it can do. If you enjoyed this video and want more explanations that break down complex technology into simple ideas, make sure to subscribe. Because the most powerful technologies in the world often start with surprisingly simple concepts, and understanding them might be more important than ever.